We'll go through few more revisional problems. Well, this is the second day of revision. We have the matrices to be revised. I gave one question yesterday just to see how you respond. Could any of you get an answer? P and Q are 3 by 3 square matrices and P not equal to Q. Given P cube equal to Q cube and P squared Q equal to Q squared P. The determinant of P squared plus Q squared. The answer is, anyone? Can any of you bring the answer? Okay, let us go. See, you have to remember one thing. I clarify once again. If for square matrices A and B, AB equal to 0 implies either one of them is 0 or both are singular. That means either one of them is a 0 matrix or both are singular, means determinant A and determinant B both will be 0. That is what we mean by singular. Not here, it is not determinant A or determinant A 0. It is both are singular. Either one of them is 0. If one of them is a 0 matrix, the other need not be singular. But if both of them are non-zero matrix, then both of them are singular matrix. Because you can see, if suppose A is non-singular, then that means A inverse exists. If you multiply with A inverse, you get B equal to 0 matrix. So one thing is if any one of them is non-singular, then the other must be 0 matrix. So either one of them is 0 or both are singular. Okay, let us see now what is given. P cube equal to Q cube and P squared Q equal to Q squared P. P squared equal to Q squared P. I also write as Q squared P equal to P squared Q. Okay, it is given Q squared P is equal to P squared Q. Okay, I now add the two equations. Which equations? These two equations, that is P cube equal to Q cube and Q squared P equal to P squared Q. If I add these two equations, what will I get? P cube plus Q squared P equal to Q cube plus P squared Q. I added these two equations. P cube plus Q squared P equal to Q cube plus P squared Q. I take from here this P cube, I can write P squared into P, and the Q cube I write as Q squared into Q. Now from these two, I take P common because we have the distributive law of multiplication that is valid from right or from left. This is P squared plus Q squared into P, right? This is Q squared plus P squared into Q. P squared plus Q squared into P equal to Q squared plus P squared into Q. But this Q squared plus P squared I can also write as P squared plus Q squared. So P squared plus Q squared into P equal to P squared plus Q squared into Q. As I mentioned earlier, if AB equal to AC, that I mentioned earlier, if AB equal to AC and if B is not equal to C, if AB equal to AC and B not equal to C, then A will be a singular matrix. Can you recollect? AB equal to AC and if B not equal to C, then A is a singular matrix. That means determinant of A is 0. So here instead of A you have P squared plus Q squared. So P squared plus Q squared is a singular matrix. That means when P not equal to Q, P squared plus Q squared is a singular matrix. That means determinant of P squared plus Q squared is 0. And the answer is A. Determinant is 0, it is A. So this all happened due to our result that if AB is 0, one of them is 0 or both are singular. That is applied there. Okay, we go for one of the questions which you have done in matrices. This can be done in various ways. One of the ways, of course, there is nothing difficult in left side. Left side is I plus A. You have to prove that if A is 0 minus tan theta by 2, tan theta by 2 is 0, then you have to prove I plus A equal to I minus A into cos theta minus sin theta cos theta. This is many times repeated question. Left side there is nothing special. I is a 2 by 2 identity matrix plus A that is added. It will be 1 and then 0 plus this, then 0 plus this and 1 plus 0. It will be nothing but 1 minus tan theta by 2 tan theta by 2. That is left side. 1 minus tan theta by 2 tan theta by 2 1. Now when you take right side, you have two options. So your left side is here 1 minus tan theta by 2 tan theta by 2 1. When you take right side, I minus a into cos theta minus sin theta cos theta. You have two options. Either you can write this cos theta and sin theta in terms of tan theta by 2. How is that? Sin theta will be 2 tan theta by 2 upon 1 minus tan squared theta by 2, and cos theta will be 1 minus tan squared theta by 2 upon 1 plus tan squared theta by 2. That is one way, and then multiply and you will get. I am not going for that. What I am doing is that I am directly multiplying. I minus A when I subtract 1 minus 0, 1, 0 minus this is minus will go plus, and 0 minus this is minus, and 1 minus 0 is 1. I directly multiply row column, first row with the first column. What will be the product of first row with the first column? 1 into cos theta plus tan theta by 2 into sin theta. I am explaining with all steps. You can reduce some steps also. What will be first row with the second column? That is 1 into minus sin theta plus tan theta by 2 into cos theta. Once you know it, there is no need of waiting. You can go ahead. Second row with the first column and second row with the second column. I multiplied the matrices. Now what I do is that I write tan theta by 2 as sin theta by 2 by cos theta by 2. Tan theta is sin theta by cos theta. So in each of these, tan theta by 2 I write as sin theta by 2 by cos theta by 2. Okay? In each of these I write tan theta by 2 as sin theta by 2 by cos theta by 2. Okay. Now I take LCM. When I take LCM in the first term, when I take LCM here, I get cos theta by 2 denominator. Numerator will be cos theta by 2 plus sin theta by 2. And the second will be minus sin theta cos theta by 2 plus cos theta sin theta by 2. Denominator is cos theta by 2. And the third will be minus cos theta sin theta by 2, that I have written second, plus sin theta cos theta by 2, that I have written first. Then the third or last term will be sin theta by 2 plus cos theta by 2. I have written cos theta by 2 first, because we know the formula like this. Cos A cos B plus sin A sin B is cos A cos B plus sin A sin B is cos A minus B, right? Whereas sin A cos B minus cos A sin B is sin A minus B. And in this term, second term, I have minus sin A cos B plus cos A sin B. That means if you take minus sign out, you have minus of sin A cos B minus cos A sin B. And accordingly, you can write this as cos A minus B, that is cos theta minus cos theta by 2. Here we write minus of sin theta minus theta by 2. And here we write sin A cos B minus sin theta minus theta by 2. Here it is cos theta minus theta by 2. And cos theta minus theta by 2 is cos theta by 2. Sin theta minus theta by 2 is sin theta by 2. And denominator is again cos theta by 2. Here also sin theta by 2 upon cos theta by 2. Here cos theta by 2 upon cos theta. And this is the right side. We know. First term is cos theta by 2 upon cos theta by 2. That is 1. Minus sin theta by 2 cos theta by 2. That is minus tan theta by 2. And this is sin theta by 2 by cos theta by 2. Tan theta by 2. And this is 1. And hence you get the left side. We have already taken the left side earlier. Well, okay, you are done it. You may revise it once again. Prove by PMI that if A is equal to 3 minus 4, 1 minus 1, then A raised to n is 1 plus 2n minus 4n, n and 1 minus 2n for n belongs to n. You could you recollect the steps to be applied to prove by PMI? First, we name a statement Pn. So what will be the statement Pn here? Pn, this is the statement Pn. A raised to n equal to, A raised to, this is the statement Pn. A raised to n is equal to this much. No need of n belongs. A raised to n equal to 1 plus 2n minus 4n, n 1 minus 2n, that is Pn. Now for n equal to 1, we can show it is true. What is left side? It is A raised to 1. What is A raised to 1? Is A. A means 3 minus 4, 1 minus 4. What will be right side? This is the right side and you put n equal to 1. The right side of P of 1, this is Pn. Left side of P of 1 is A. And right side of P of 1 is instead of n you put 1. So 1 plus 2 into 1 minus 4 into 1, 1 and 1 minus 2 into 1, which is equal to 1 plus 2, 3 minus 4, 1, and here 1 minus 2 minus 2. Both are same. That is equal to left side of P of 1. So P of 1 is 2. Right? You can write here you can write. So P of 1 is 2. I missed that. We can write P of 1 is 2. Okay? Now, let P of k be true for some k belongs to n. Let P of k be true for some k belongs to n. What do we mean by that? P of k, that is A raised to k equal to 1 plus 2k. Instead of n, you write k. A raised to k is equal to 1 plus 2k minus 4k, k and 1 minus 2k is 2. For some k belongs to n, your P of k. What are we to prove? We have to prove that P of k plus 1 is true when Pk is true. So we already assumed Pk is true. We have to establish P of k plus 1. What is P of k plus 1? You have to prove A raised to k plus 1 equal to 1 plus 2 into, instead of k, we write k plus 1. 1 plus 2 into k plus 1 minus 4 into k plus 1 and 1 minus 2 into k plus 1. This is what we have to establish. P of k plus 1. We start with what is left side and we reach to the right side. What is the left side of P of k plus 1? It is A raised to k plus 1. What is A raised to k plus 1? A raised to k into A. A raised to k we already have. What is that? 1 plus 2k minus 4k, k and 1 minus 2k. Multiplied with A raised to 1. A raised to 1 is A. That is 3 minus 4, 1 minus. Again we apply row column. First row, first column. What is first row with first column multiplication? 1 plus 2k into 3 plus minus 4k into 1. Further, first row into second column. 1 plus 2k into minus 4 plus minus 4k into minus 1. Further, second row with the first column. Further, second row with the second column. On simplifying, you are getting 3 plus 2k and minus 4k and k plus 1 and minus 1 minus 2k on simplifying. Now you have to show this is as good as this. The right side 1 plus, see 3 plus 2k. We can write 1 plus 2 plus 2k or 1 plus 2 into k plus 1. And minus 4k you can write minus 4 into k plus 1 and k plus 1 is as it is. Minus 1 minus 2k you can write as minus 1 minus 2 into k plus 1 minus 2k minus 2, that is as good as minus 1 minus 2. So what we conclude is P of k plus, that is equal to right side of P of k plus 1. So P of k plus 1 is true when P of k is true. So that is how we establish some result using PMI. We make the statement Pn, we verify it for n equal to 1, we assume the result is true for n equal to k, and using that assumption we establish for n equal to k plus 1. Do this very neatly. This is a very regularly asked question, and that means when P of k is true, P of k plus 1 is true. but P of 1 is 2. So for now it is the induction principle. So for by PMI, Pn is 2 for all n. Okay, let me ask you a question. If I wait for a minute, can any of you respond with your answer if you have pen and pencil, or simply if you calculate? A is a matrix, B is a matrix, both are 3 by 3 matrix. Find the value of x so that AB is an identity matrix. If I wait for a minute, can some of you bring an answer? Find the value of x so that AB is an identity matrix. If AB is an identity matrix, then find the value of x. Shall I wait for your answer?
Yes, sir. Just a minute.
I'm waiting. Should I give hint?
Sir,
Ah,
sir, if AB is an identity matrix,
yeah.
then like what is the relation between them?
When you multiply,
Multiply,
A,
we get the identity matrix.
A into B is equal to 1 0 0 0 1 0 0 0 1. A into B equal to 1 0 0 0 1 0 0 0 1. Still not the answer.
Sir, calculating.
That means you went wrong way. Otherwise, it doesn't take even as a 10 or 15 seconds.
Sir, 1 by 5?
So you didn't, you got it. Look at the first row and first column. First row and first column. When you multiply, you get 1. 2 into minus 6. Minus 6 plus 7x. That is 5x. 5x equal to 1. So x equal to 1 by 5. How much
Oh,
time
yes,
is it?
yes, sir.
Correct?
1 by
All
5.
the rest we can easily verify later. All the rest satisfy the same. So that is how when you encounter, especially this, I can ask as a MCQ. When you write MCQ, there you are not going to prove too many things. You will be getting the answer in the easiest way. Okay, let us go for this anyway. I am not waiting, taking your time now. You have to do it. Well, from tomorrow, from Monday when we proceed, I will be more oriented in an MCQ way, because you may have to encounter MCQ also. Okay?
Sir,
Ah,
will you be uploading the recording on Skype or YouTube?
YouTube. Skype, actually, I am not the administrator, so can I upload it? I don't know whether it is possible or not.
Sir, you can upload it on Skype also, so.
In Skype, I am not the administrator, so will I be able to do it? I do not know.
Yes, sir. Yes, you will
Yes,
be
sir.
able to upload it.
Okay, I'll
It
try.
doesn't matter who's the
I'll
admin.
try. Anyway, it is recorded. I'll try to upload it. You see one question I written on board, those who came late. If for square matrices A and B of same order, right? AB equal to A and B equal to B, we have done it. Prove that A squared equal to A and B squared equal to B. A squared is A into A. I have written AB because AB equal to A. And we have done it. You can easily show B squared equal to B also. Okay. We'll end for today.
Also, sir, if you
Ah.
also, sir, you've uploaded the last 2 days recording on YouTube.
Yeah, I will record it all. YouTube it is there.
Okay, sir.
Okay. All the best. We'll meet back.